Hello and welcome again to the channel here, the Advanced Level Mathematics channel, where we practice past examination questions for the purpose of preparing students for their advanced level mathematics in the Cambridge Advanced Level Mathematics examinations. Our question today is question number 4, taken from paper 2 of 2020, and the question reads as follows. Question A says, solve the equation 5 to the power 2x plus 5 to the power x is equal to 12. Question B says, it's given that ln brackets y plus 5 minus ln y is equal to 2 ln x. Express y in terms of x in a form not involving logarithms. Inside the blue box here, I've just quoted a couple of laws related to logarithms and indices. The first one says the logarithm of a multiplied by b is equal to logarithm of a plus logarithm of b. The second one says the logarithm of a divided by b is equal to logarithm of a minus logarithm of b. The third one says the logarithm of a raised to the power x is equal to x multiplied by logarithm of a. I believe these three laws are going to help us extricate ourselves from this terrible and unfortunate predicament that we find ourselves in. Let's see if we can tackle the first part of the question there. I'll write it over here. It says 5 to the power 2x, 5 to the power 2x plus 5 to the power x is equal to 12. That's what it says. Now what do we do here? Okay, let t equal to 5 to the power x. Now, if t is equal to 5 to the power x, then what is 5 to the power 2x? Well, 5 to the power 2x can actually be written as 5 to the power x or raised to the power 2. That becomes t squared because this is t. So this can be written as t squared. Now we are in business because here we can now write t squared plus t is equal to 12. Rearranging, we have t squared plus t minus 12 is equal to 0. We're now dealing with a good old quadratic equation, which we can factorize to, this factorizes to brackets here, brackets there, brackets there, brackets there. That's your t there, that's your t there. What are the factors of minus 12 that add to 1? Is it 2 and 6? No. Is it 1 and 12? No. Is it 3 and 4? Sounds like. So let's put a 4 here and a 3 there. So what must we do to the signs of 3 and 4? The 4 must be a plus and the 3 must be a minus, so that we get a plus 4 and a minus 3 to result in a 1. And this, of course, is equal to 0. Now, straight away now we can say, therefore, t is equal to 3 or t is equal to minus 4. But what is our t? Our t is 5 to the power x. Now, so either 5 to the power x is equal to 3 or 5 to the power x is equal to minus 4. Now, this is impossible. There is no number that we can raise. There is no number x we can raise 5 to give us a negative 4. So this is discarded. We discard this solution and we are left with 5 to the power x is equal to 3. Of course, we can take now logarithms to base 10. So we can say on both sides, of course, log to base 10 or 5, our 5 there, raised to the power x is equal to 3. Sorry, not 3, the log of 3 is equal to log of to the power to base 10 of 3. Okay, now we can now resort to that law. Our 5 is raised to the power x, so law number 3, it becomes x log of 5. So we can now say this is equal to x logarithm to base 10 of 5 is equal to logarithm to base 10 of 3. And of course, dividing both sides by log of 5, our x then becomes log to base 10 of 3 divided by logarithm to base 10 of 5. Yeah. We just punch this in our calculator. So we have log 3 is equal to that. Let me store it in A. So then I have log 5, which is that inverse, which is that times, recall A, which is that. It's about 0.683. So x is equal to 0.683. So in other words, 5 raised to the power 2 times 0.83 plus 5 raised to the power 0.83 is equal to 12. You can try that in your calculator to see if it works. But that's the answer to part A of question 4. Let's proceed to question B. I think we should clear our board and create some space over here. Now, this is a pretty straightforward problem. If you have got the laws of your logarithms and indices on your fingertips, that's the trick here. This is a rather stubborn ink I'm using, and it clears after some struggle, but eventually it actually clears. Okay? All right, there we are. So now the second question says it is given that ln brackets y plus 5 minus ln y is equal to 2 ln x. Express y in terms of x in a form not involving logarithms. Right, let's rewrite our thing as before. So it says ln y plus 5 minus ln y is equal to 2 ln x. Right, let's put the laws into gear here. Here on the left-hand side, we have the sum of 2 logarithms. We are here. So this enables us to do that. So on the left-hand side, log of this minus log of that can be written as using our first law, our second law, sorry, the one that says minus. So it becomes ln brackets y plus 5 divided by y, okay, divided by y is equal to, on the right-hand side, we have to apply this law again. Remember, we are here on the left-hand side, on the right-hand side. So it enables us to do that. So that means that this is equal to ln x2. The 2 becomes a power there. Right. So if the two numbers, if the logarithms of 2 numbers are the same, then that means that those numbers are equal. If I am given that ln or logarithm of b to any base is equal to logarithm of c to the same base, then b is equal to c. So we can equate y plus 5 divided by y is equal to x squared. We take our y over to this side. That becomes y plus 5 is equal to x squared y. I cross multiply. I just multiplied everybody by y. Then let me take this other y to that side. I am left with 5 is equal to x squared y minus y. Factorize. This implies 5 is equal to y brackets x squared minus 1. Dividing both sides by x squared minus 1, I have y is equal to 5 divided by x squared minus 1. Now I have expressed y in terms of x in a form which does not involve logarithms. Finally, we managed to get out of the pit. What enables us to do that is the ability to manipulate the laws of logarithms and the laws of indices. That's all for today. Till next video. Thank you very much.